Okay, so the same problem, one problem we'll take, and we will try to simulate the same problem using multisim also. So consider the problem. They have given all the resistance and voltage values. VCC is 10 volt, RC is 1.5K, RB is 270K, and RE is 1K. So they have given beta is 50. So I cannot use 100 as in the previous problem. I have to use the value of beta as 50. Okay, beta is going to be 50. So with that, I'm going to find the parameters. So see the first thing, stability factor. See, all these formulas you have to remind. So stability factor is 1 plus beta by 1 plus beta into RE by RE plus RB. So substitute everything and you get the value as 43.04. 1 plus beta is 51. Ideally, for the very first circuit we have seen, the stability factor is 51. Now, because of adding an emitter resistance, you see, it has come from 51 to 43.08. We have reduced the value of stability factor. And the expression for IB, IC, VCE, VC, they have asked everything. So by using the corresponding equation, you can find everything, VE, VB, and VBC. So all the voltages you can find. VBC means VB minus VC. VB means VBE means VB minus VE. From that you can find VB, VBE plus VE. VCE, VC minus VE. From that you can find emitter voltage. So they have asked in the question everything. So we have found out everything, the stability factor, the expression for base current 28.97 microamperes, IC is 1.45 milliamperes, VC is 6.38 volt, VC is 7.825 volt, VE emitter voltage is 1.45 volt, VB is 2.15 volt, VBC is 5.675 volt. Why we are finding why the individual voltage of VB, VE and VC are asked here means because when there is no resistance at the emitter side, it is directly grounded. So whatever VB you find, it will be equal to VBE. Whatever VC you find, it will be equal to VCE. But since you have an emitter resistance here, the value of VCE will not be equal to the value of VE. The value of VB will not be equal to the value of VBE. That is why in this problem they have asked us to find the individual voltages, voltage at collector, voltage at emitter, voltage at the base. See, this is simply applying the formula, so I don't want to explain this problem as such because it is very, very simple. Okay, so we'll just switch over to the